Eclss, Environmental Control and Life Support System. The main goal of the Eclss Library of EcosimPro is to model and simulate the environmental life conditions in a spacecraft cabin and its life support system. The Eclss Library is the standard library of the European Space Agency for the modeling of environmental control systems. Other users such as NASA, EADS, ELINI, etc. have used this library to design different modules for the International Space Station. Eclss modeling involves multidisciplinary simulation with different phenomena such as fluid flow, chemical reactions, electrochemical reactions, heat transfer, biological processes, etc. The Eclss library includes thermodynamic functions to calculate the properties of the following working fluids: pure real gases of water, coolants of pure substances, perfect gas mixtures with or without water, where water can condense as a solid or liquid. The Eclss library includes the following components. The symbols of the library. We will now describe some of them. The Electrolyzer component models the electrolysis process, the usual approach for generating molecular oxygen. The Electrolyzer model is an immobile system where the KOH electrolyte is contained within a porous matrix. This component represents pressure losses in the grid. The formulation considers pressure losses, gravity and inertia forces in the momentum equation. The flow is assumed to be adiabatic and the thermal delay is not taken into account. This component provides a representation of the heat exchangers. The main assumptions are as follows. The heat transfer rate is calculated from the effectiveness formulation. Two control volumes, hot side and cold side. Mass storage is ignored. Momentum equations are taken into account. The reactor carbon formation component provides a simplified representation of a carbon formation reactor. It breaks down the methane into solid carbon and hydrogen. The formulation assumes that there is no storage of mass in the reactor except for the carbon generated in the reaction. This demo shows the functionality and the potential of this library using EcosimPro, a powerful mathematical tool capable of modeling any kind of dynamic system. The following example focuses on a model of an air management system. Air management system. Model to be built. A system consisting of a cabin that transports 3 astronauts during one day. The temperature, pressure and mass balances and the crew metabolism must be taken into account. Goals: to trace the evolution of different variables, temperature inside the cabin, humidity level, CO2 removal process and partial oxygen pressure during the period. The design objectives established for the development of this Eclss library were to provide an easy-to-use, fast calculation tool. This library provides a set of components to model the most typical equipment and processes of Eclss systems, cabins, crew members, hatches, etc. All the components are modeled with an EcosimPro object-oriented language called EL. The code of the cabin is then shown. The EL language allows the following: definition of ports for the connection of component with other components, definition of data variables, the definition of variables to be calculated in the model, the initialization of calculated variables, the introduction of algebraic and differential equations in a discrete and continuous block. Let's return to the schematic view and create a new diagram. The problem set out at the beginning will now be built connecting the required components. First of all, the cabin is selected and connected to the other components until the schematic diagram is completed. It represents a standard air volume or cabin. Three parts are modelled: an atmosphere part, a wall part and a condensed film part on the wall. The O2N2 symbol is used to control the partial oxygen pressure. The crew component represents crew members. It is connected to a cabin component through ports designed to represent exchanges between live beings and their environment. The CO2 removal symbol contains a group of components. The goal of this is to control the amount of CO2 in the cabin. Using the attribute editor, the data variables defined in the source code of the component can be modified. And the resulting schematic diagram is as follows. Model of an air management system: cabin, crew, oxygen control, temperature control and space. The final schematic diagram is compiled and the mathematical model is then generated. The simulation view is then selected. Mathematical models do not necessarily have any experiment files. However, the model used in the example has one experiment file. The user introduces the initialization of dynamic variables, the values of boundary variables, and other parameters. The experiment is compiled and simulated in the monitor. The monitor shows the evolution of the selected variables in several plots. The simulation is run and the final result is as follows. This plot shows the metabolic activity rate of one crew member. This plot shows the temperature control system. The final plot shows the evolution of the air composition. If you have any questions or comments, please contact us at info@EcosimPro.com and visit our website www.EcosimPro.com for further information.